All right, welcome to Good Choices for Real this time. I didn't have my audio going, but I only made it about 5 minutes through, and most of that time I was verifying where I actually was. Last video was lesson 103 was topic 103.4, which is using streams, pipes, and redirects. We got all the way through lesson 1 in 2 parts. So that brings us to lesson 2 in the same topic. So the introduction. One aspect of the Unix philosophy states that each program should have a specific purpose and try not to incorporate features outside its scope. But keeping things simple does not mean less elaborated results, because different programs can be chained together to produce a combined output. The vertical bar character, also known as the pipe symbol, can be used to create a pipeline connecting the output of a program directly into the output of another program, whereas command substitution allows to store the output of a program in a variable or use it directly as an argument to another command. Pipes. Unlike redirects, with pipes, data flows from left to right in the command line, and the target is another process, not a file system path, file descriptor, or here document. And here documents, you can do that with 3 less than signs. The pipe character tells the shell to start all distinct commands at the same time and to connect the output of the previous command to the input of the following command, left to right. For example, instead of using redirects, the content of the file /proc/cpu info sent to the standard output by cat can be piped to the standard input of wc with the following command. All right, and I'll try that in my lab. So cat /proc/cpu info pipe wc. There we go. Yeah, and that makes sense. They're probably not using a blade server like I am. It's probably just on like a laptop or something. So I've got a lot more cores than they do. CPU. There's a lot more CPU info on my home lab than there is on their laptop or desktop or whatever they're running this on. In the absence of a path to a file, WC counts the number of lines, words, and characters it receives on its standard in, as is the case in the example. Many pipes can be present in a compound command. In the following example, 2 pipes are used. So here's what we're going to do. We're going to cat this, and then the standard output of that, or I'm confused if this is standard output to this command, or if it's standard input to this command, or if it's the other way around. This is standard input to this, or standard out. I'm not sure. So here's the answer. The pipe character tells the shell to start all distinct commands at the same time, so these are all running at once, and to connect the output of the previous command to the input of the following command. So what happens is we do this, and then the output of this gets fed into this as input. So, and that makes sense because grep would normally work like this. So if I try just grep model name, so let me do a grep help. So grep pattern. So we're not feeding it a file. So I guess I'm not sure what it does. Oh, here we go. So if there's no file read, then it will grep it this dot. So this is what we're doing. We're doing grep model name, and then we're looking for model name like that, just in all the oh, no, we're not. Wait, I'm confused. Okay, I'm not sure what's going on here. So we have to give it. So we don't have to give it options. Options are optional. We do have to give it a pattern, and then we have to feed it a file. So like here's an example of how this works. grep-i, so it's case insensitive, and now we've fed it files to look through. But down here it says if a file is not there, then it would read this dot, and if recur. Oh, I see. If recursive. So if recursive. So you by default it's not recursive, and you make it recursive by feeding it the option -r. So if we were to do this grep-r model name, it's gonna hang because it's gonna look through, but we're no longer gonna have that error. Yeah, because yep, there we go, perfect. Okay, see what I mean? See what I mean? So I know what I'm talking about there. What it actually does by default in this case when there's no recursive option is it does it on this dash character. Now I don't know what the dash character is, so let's try to find out. So let's do maybe man dash. That would be nope. Just enter a dash. How about file dash? I'm trying to figure out what the dash command is. What if we do like ls dash? How about cat dash? So cat dash looks like it does something. I mean, we can see that this works. So let's do this. Let's do this. We're gonna go to the AI. I love that I can do this. Like, you know, it is the year 2023. Like, I think this might have been released last year, but you know, this is a game changer. So what is the dash character in this case? Why is it the default thing fed to grep if you don't include a file and don't specify the recursive option? This is like so good.
Let me explain what's going on, and let's keep in mind your bigger goals of mastering medium-level LeetCode questions and passing the NCore Cisco exam. In Unix-like operating systems, the character often represents the standard input, stdin, or standard output, stdi, of command line utilities. When used as an argument, many commands will read from stdin if a file name is not provided. grep model name. Here, it tells grep to search the standard input for the parent model name. Since you didn't pipe anything into grep, it's waiting for input from the keyboard, hence you had to use --c man. The command man is expecting a command or configuration file to provide a manual page.
See what I mean?
Here,
like,
so you're getting an error message.
See what I mean here? Like, this is so good. So here we go. So let's do this. Grep model name and then dash. Now let's type model name. I found it. Now let's type blah 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 model name blah 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 blah. It found it. See, like, this is what it. Yeah. Okay. So this here, blah, 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 this is the standard input. It's anything I type blah, 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 from my computer or from my keyboard, that is standard input. So what grep does by default is it searches for this string in the standard input. So blah 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 blah, and then blah 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 model name. Blah, 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 blah. There it is. It found it in red there. So that's actually pretty useful because like if you want to like say like let's say a show run example, and then you just want to see like you know, like you just want something highlighted in red. So let's say that shoot, I want to see a show run that's not I mean I could get one myself from my home lab. I'll create a I'm pretty sure I had a let's get one from let's get one from this like route lab, because this one is from oh, and I think I didn't start up my there we go. So this is from a David Bumble video, so it should have like pretty interesting show runs. So let's get the show run for ISP3. If anyone's not heard of David Bumble, DAVID BOMBAL, look him up on YouTube immediately. Stop watching this and go over and watch his content. People like Jeremiah Wolf, that's another one to follow, and perhaps to stop watching this and go watch him right away. Don't have a lot of respect for, you know, that sort of thing, because what David Bumble is doing is he's in some sense trying to build an audience. So, you know, that means talking about, that means attracting attention. So it's like, you know, hack this, cybersecurity that, secret this, you know, it's entertainment on some level. And he has some wonderful content that's like motivational content, like, you know, use your time for things that pay you back as much or more than you pay into it. Like that's a really good message. That's something I had to kind of realize when I wanted to be a professional musician, is like, you know, I'm practicing, you know, a few hours a day at my best. At my worst, you know, I'm practicing like a half an hour every day. It's like if I do something else for a half an hour every day, 15 minutes every day, like even just like exercising, but like, you know, learning to code or something, it's like I'm not gonna be broke and starving, you know, the starving musician thing. Like I'm gonna have a decent job in like coding, or like at the very least I'm gonna like be fitter, more in shape. So it's like, yeah, music's great, and you can get a lot out of it. So like if that's the case, then yeah, like put a lot into it. But like if you got to the point like I was, where it's like I put in like 10 years of like into it, and like I just put like a lot into it, and it's just like you look at the end of the tunnel, it's like, what else do I have to do? Like, do I have to get a PhD? Do I have to practice 4 to 5 hours a day, 8 hours a day? It's like, you know, it's just like you're putting your coin into a gumball machine, and like the gumball that comes out is like, you know, a micro-sized gumball. Like you could go to a different gumball machine, put in your coin, and get a massive bowling ball sized gumball out of it. And that's kind of how I feel about IT. So it's like that I learned that, I kind of reinforced that message and heard it explicitly. I kind of learned it on my own through the School of Hard Knocks, but like I've never really heard anyone like explicitly say that until I was watching David Bumble videos. So like it was really nice to hear that. It's like I think that analogy holds true. Like put your coin in the gumball machine, and then take a hard look at those gumballs that are coming out. What size are they? How do they taste? Are they fresh? Are they old? This is just an analogy. And then like, really think about, does it make sense to keep putting coins in this machine, or do I need to put coins in a machine where I get better return? So I had to make that pivot. I had to say, music's great. I love it. I got a lot out of it. But as much as I got out of it, I could get more out of something like IT, and get like financial stability, do a wider range of like things I'm interested in, because I'm interested in this. Like, it's fun. I like definitely playing music a lot still. But that's how you can determine what you should do avocationally, and like in an amateur sense, like just for the love of it, not to get paid for it, and like what you should do to like earn your living. Like, to earn your living, you should get as much or more out as you put in. So if you spend, for example, like just hypothetically, a Stradivarius is like $1 million. So, okay, you go and buy a Stradivarius. Are you going to break even on that? No. You're going to be out probably the full $1 million, if not more. Okay, well, a home lab costs $600. Are you going to break even on that? Yes. Like, you get your, you're going to have to pay another $400. You might have to pay, let's say, another $1,000 for learning materials. Let's say another $5,000. That puts you at $6,000 or like $10,000. Like, Jeremiah Wolf went through his study for the CCIE, and $30,000 is like the max to spend. He spent like, I think, like $20,000. Well, that's like a quarter. That's like a fourth. That's like a third of your salary for the year, at minimum. Like, if you are bad at like taking interviews and like having a resume and like going through the whole process of getting hired, that's like the minimum you will make for having a CCIE. So like, look at that difference. It's like a CCIE is a major undertaking, but it's a major undertaking of a year, of 2 years. A professional musician, that's a major undertaking for your whole life. Like, professional musicians are from professional musician families. Usually they start playing when they're like 2 years old. They get special made instruments, and they get private lessons from their family members, from the best teachers in town, since they're 2 years old. And they practice a lot. And it's like, what do they get out of it? If they get a lot out of it, great. If they make a good career on it, great. That's amazing. But, what is that margin? Especially if you're doing it every day for hours a day since you're 2 years old. And now you just broke into your career at the age of, let's say, like 12 or 14. You're an absolute prodigy. Well, you've already been doing it for 10 years at that point. So like, imagine getting a CCIE in 1 year, and then, look at the margin after 10 years for that. It's $1 million. Like, and there you go. It's like, you could buy, a Stradivarius as a CCIE, a home lab that costs $1 million, and you could break even on that. And then after 20 years, you could make all that. You'd net a profit of you'd make $2 million after 20 years. So, yeah. Well, anyway, that's David Bumble for you. Just go look him up. There's more than just that. He has like detailed labs. He teaches like paid courses and stuff. Like, you'll see him all over. He's not just an entertainer. He's a real guy in the network engineering space. So, kind of going on too long about that. All I want is a show run. So let's do show run. All right, so I got my show run, and now let's say let's say this show run, because I've seen show runs on the job that are like so big, you can't just read the show run because it's just like massive. So like so big that like even copying it off the device like that is like, it's just, you have to scroll back so much. Like, it's better to get it off like programmatically. So like screen scraping is a hard problem because it's so big. But here's a way you can use grep to search the standard input. So we can do grep, we can do interface, and now without anything, or this is the default character, it does the same thing. We can hit enter, paste anyway, and here's the results. So there we go. We've got a match on interface there. We've got a match on interface here. So, this could be useful. Unfortunately, it looks like what it does is it reprints it, kind of in not an ideal way. It'd be nice if it. So it looks like what it does is it takes the standard. It returns standard output. So like this is all standard input, and then this is standard output here, and then here's more standard input. So like it does, or like, oh, this whole thing is standard output. So it takes the whole line that it matched on, and then it duplicates the line as standard output. But it doesn't even do that because it's like IP. It's like, yeah. So unfortunately, not the best way. There's better ways, but I think the point still stands that if you want to search the standard input for whatever reason you would want to do that, you have the ability to do that. All right, so I'm going to shut this down. And then I'm going to keep on going here. So in the absence of a path to a file, WC counts the number of lines, words, characters it receives on its standard in. As is the case in the example, many pipes can be present in a compound command. In the following example, 2 pipes are used. All right, so let's do that. And there we go. We've got so it goes this way. So the standard output from cat gets put into grep. So like before we had it gets put into grep as standard input. So like normally the standard input would come from the keyboard, as we saw. So if we do grep model name, now it's just going to hang because it's waiting for standard input. We give it that standard input, and it will match on the standard input. If we give it something where there's no match, then it won't return any standard output. So that's key to know, because the standard output from cat gets put into the standard input from grep, and then since there is a match, and the match is here, so then this whole line, what grep does is when there's a match, it creates the whole line as standard output. Now that it gets fed to unique as standard input. So for unique, we should see a similar thing as grep, where it can accept standard input. So, yep, so from input or standard input, there we go. So if we just run unique, UNIQ, without anything, it just hangs there. It does nothing. So you might think, this is one of those things too. Like if you've been using Linux for a while and like you see something like this, you might think, oh no, it's hanging. Like there's so much going on with this command that it's just, hanging out there. And I have to hit a Control-C or Control-Z to stop it from doing so much. Well, it's not doing anything. What it's doing is it's waiting for your standard input. So, and we can see it's producing standard output from all of this standard input. So there we go. I believe I understand the difference between standard input and standard output now. And not only that, I understand that commands like grep and unique accept standard input. And in fact, if you don't specify input other than the standard input, then it collects standard input by default by waiting for keyboard for standard input from the keyboard. All right, so the content of file/proc/cpu info produced by cat/proc/cpu info was piped to the command grep model name, which then selects only the lines containing the term model name. The machine running the example has many CPUs, so there are repeated lines with model name. The last pipe connects grep model name to UNIQ, which is responsible for skipping any line equal to the previous line. Pipes can be combined with redirects in the same command line. The previous example can be rewritten to a simpler form. All right, so we're going to simplify that previous example. So instead of doing a pipe here, and then doing so, instead of feeding the standard output of this to the grep command as standard input, so what we can do is we can redirect the standard output. Oh, you know what we can do? So yeah. We can redirect the standard output of this into grep as standard input. So if we were to do cat, or if we were to do this, hello, echo, hello world. Now we could redirect the standard output to a file, and we would do that with the greater than sign. So let's do file.txt, let's do cat file.txt, and the standard output of this echo command no longer shows up in the bash output because it was redirected to this file, and we see the file has it there. So that's redirecting standard output. The other thing we could do is we could redirect standard input. So if we do the echo command and do a help, let's do the echo command with nothing. Okay, well, you know what? Let's do this. Let's use something like grep that, or unique is the perfect one. So unique, just on its own, takes standard input. And if you don't specify the input, the input for it to take, it takes standard input, or it takes input from files or anywhere else that isn't standard input. Standard input comes from your keyboard typically. So if you don't give it any input, by default it will take input from your keyboard, which is sent to the standard input file 0. There we go. But the other thing you could do is you can redirect output from a file, so file.txt, into this command as input. And there we go. We can see everything went perfect. Another thing we can do is we can use grep, for example. And we're going to search for hello. And if we did it without anything, it would take it from the standard input, which just comes from my keyboard. And then if we type hello, we've got a match there. But another thing we can do is redirect input. Instead of from the standard input, we can feed it the input feed it to the output of this file as input to the command grep. And you can see there we've got a match hello world. So that's probably a better way to do the show runs, because then the output, because then you don't see both of those. So if we do this show, so if we do this vi show run.txt set paste I, and then we go and grab one of those show runs, the bigger the better. So like these C routers probably have pretty big show runs, like an area border router. This one probably has a smaller one. I mean, I guess it's a route reflector. Let's try this one. Hopefully that's a bigger one. Shouldn't take too long. I've got a pretty decent lab. I'll probably, if I bought it again, get more CPU. You can see the CPU's at 55, the RAM's at 4.4. So I've got 96 of RAM. I could do half of that. I don't know if it's like exponential or whatever. Like, I doubt it would be like, 8.8 if I did half the RAM. But the fact is that if I had more CPU, it wouldn't be, at 60 for this sort of lab. Because these are not very CPU hungry devices. Like the Junipers are a lot more CPU hungry. So you can see it, it falls back down to 6, but whenever this spikes up to 60, 90, 100, then that really introduces a lot of latency. All right, so yeah, this is a fairly substantial show run. So let's put this in the clipboard. All right, there we go. I've got it in the clipboard. Now let's paste it in as a file. All right, looks good. And then let's pipe the context of the file. And we'll look for interface like we did before. But now we're going to pipe the output of the file show run into the input of the command grep. And there we go. Now what we get back in bash is the output from the command grep. Nothing more, none of the input. So all we've got is the matching lines and nothing else. Probably not ideal, not exactly what we're looking for here, but that is just hopefully a good lesson into the difference between input and output in bash. All right, so the input redirect for bash is not strictly necessary, as grep accepts a file path as argument, but the example demonstrates how to build such combined commands. Pipes and redirects are exclusive. That is, one source can be mapped to only one target, yet it is possible to redirect an output to a file and still see it on the screen with program T. And I've used T. I've come along T in the real world. So what T does is it redirects. Okay. So to do it, that's no good. That's not good at all. I completely lost everything. Okay, here we go. To do it, the first program sends its output. I'm going to do a sound check. It'd be horrible if the sound... I mean, the sound's a little low right now. It depends on... Anyway, so to do it, the first program sends its output to the standard in of T, and a file name is provided to the latter to store the data. So I guess you can think of T as kind of like a golf tee. So the ball on the tee, when you place the ball on the tee, oh, I did tree, not T. The command is T. So, and this is one of those commands where, it's waiting for standard input from your keyboard. So you can think of that as like placing a golf ball on a tee, and when you hit enter, you swing the golf club and you hit it off the tee. So you get the standard output. So all T does is it converts standard input to standard output. So if we were to do this again here, the standard input, you know what, let's just try it and see what happens. Okay, so it didn't fix anything. So it didn't change anything. So what we can do is we can convert standard input to standard output, and we can do that with T. So what we're going to do is we're going to do T pipe, and then we're going to take the standard output from this command, which are all of these, and we're going to feed it to standard input for T. Okay, interesting. That is really interesting. Yeah, because, okay, and we can see how this works. See, like, here you're taking the standard, so you're running this against the command T, and that's why you have no highlighting here, because the standard output of this grep has the highlighting, but T doesn't do any highlighting. So when you take the standard output with this highlighting and you feed it into T, and you convert that standard input that you fed to T, which has this highlighting, when T converts it to output, it does not preserve the highlighting. But when you take the standard output from T, which is just what comes from your keyboard, and then you feed it into this command. So what happens is it runs this command, which the standard output from the grep command has the highlighting, and then it hangs and it waits for your, because it didn't get any standard input. So by default, what it does, or it didn't get any input. So by default, what it does is it collects standard input by way of your keyboard strokes. Boom. So there we go. So that's what T does. T converts standard input to standard output. T does not preserve things like highlighting. So if your standard input has a highlight and you convert it to your standard output using T, it won't preserve that. So let's take another look at T, the help. So copy standard input, and you can do it to a file, but also to standard output. Oh, that's interesting. Okay, well, let's try this. So if we were to do this, and then we can give it example.txt. So now this is not highlighted, but example.txt should be highlighted as far as I understand. Okay, example.txt is not highlighted. Maybe it's because cat doesn't preserve the highlighting. Yeah, that's interesting. I don't know. I was expecting it to be highlighted, but because I was expecting this to be standard input, which is highlighted, because the standard input is the standard output from this command fed here. And then we can see the standard output comes here. So I was expecting the standard output that was fed to bash, the bash prompt, bash command line, to not be highlighted, but the contents of the example file to be highlighted. That's what I was expecting. But I don't know. It could be because of cat. I wish there was a way to like mark the difference between standard input and standard output. Yeah, I know there's a way you can specify specifically whether it's standard input or standard output, and you do that with a number here. But anyway, this proves nothing. Don't know whether this is standard output and this is standard input, but the highlighting is not printed out because we're using cat, or if both of these are standard input or standard output, or this is standard input and this is standard output. Really no way to tell, so let's just move on and consider that a failed experiment for now. So pipes and redirects are exclusive. That is, one source can be mapped to only one target, yet it is possible to redirect an output to a file and still see it on the screen with program T to do it. The first program sends its output to the standard input of T, and a file name is provided to the standard input of T to store the data. So doing just what I did there, we're getting standard output via this command. Then we're sending it to this command as standard input, so it doesn't hang there and wait for strokes from your keyboard, because the standard input comes from here. And then the standard output now gets fed to the standard input of T, which is automatically saved to this file, and then or which is written to this file as standard output, and we can see that in here. So, oh no, never mind. So the standard input is written to this file. The standard output is written to the CLI. So this here is standard output. This here is input. It's not standard input because it's not coming from the keyboard. It's coming from the results of an application. The output of the last... Oh, and I need some water here. Perfect. Okay. The output of the last program in the chain, generated by unique UNIQ, is displayed and stored in the file cpu_model.txt. To not overwrite the content of the provided file, but to append to it. Oh, that's cool. The option -A must be provided to T. And I bet you if you enable the no clobber option with set minus capital C, then it would disallow you from using T to overwrite files. Only the standard output of a process is captured by a pipe. Let's say you must go through a long compilation process. Oh, compilation process on the screen, and at the same time save both the standard output and the standard error to a file for later inspection. Assuming your current directory does not have a make file, we're going to learn about make files. I need to know about make files. They're so relevant to like Python. I'm really glad I'm going to learn about those. The following command will output an error. So make, then what we're doing is we're redirecting the standard output of make to the standard input of T, and then what T does is it converts the standard input to the standard output, and if you specify the name of a file, it will overwrite the file if it already exists with the standard output from the command to the left of the pipe, or it will create that file and then the file will have the same contents. So although shown on the screen, the error message generated by make was not captured by T, and the file log.txt was created empty. That's because there is no standard input fed to the make command. So the standard input was converted to standard output the input, not standard input because it didn't come from a keyboard. It was converted to output by the T command, and then saved to that log.txt file. There was no standard input, so the file is blank, but we do see some standard output. Actually, we see standard error. We don't see standard output. So although shown on the screen, the error message generated by make was not captured by T, and the file log.txt was created empty. A redirect needs to be done before a pipe can capture this standard error. So redirect, standard error, remember, is 2. 1 is standard out. 0 is standard in. And then these are, file names. So like 3 through 4, like 3 through infinity are like names of other files and like custom files. So what you do is you can do the make command, and then you feed the standard the input that you feed to make is a redirect of the standard error to the standard output, and then that is now standard output. So you feed that redirect. I'm not sure what the ampersand does, but you feed it to the input of T. So now the standard error is saved to the log.txt file because the message in the standard error is now converted to input. In the example, the standard error of make was redirected to the standard out, so T was able to capture it with a pipe, display it on the screen, and save it in the file log.txt. In cases like this, it may be useful to save the error messages for later inspection. All right, this is a pretty long lesson, so let's take a look at the time. Okay, so we're at 40. I like to cut these off at about an hour. Oh, you know what? This one isn't so big. Why is it? Oh, I guess it's just like the fatness is. Even though I'm at the top, it's like it's pretty fat. This is like fat, so it should go pretty fast. Pretty fast. So command substitution. Another method to capture the output of a command is command substitution. By placing a command inside back quotes, which are not single quotes, not double quotes, they're back quotes. And I usually call them like back ticks, so kind of good to know that they're calling them back quotes. That makes more sense to call them that. Bash replaces it with its standard output. The following example shows how to use the standard out of a program as an argument to another program. So what we do is we take the command date, we provide input to the command date here, and then the standard output of this command date we convert to standard input using the backticks, and we convert to input, not standard input. Yeah, oh, no, it is standard input. I don't know whether it's standard or not. But anyways, whether it's standard or not, it still is input, which was converted from output of the date command. So now we have that output from the date command converted to input, and since it's input, we can give it to the make directory command. And now we made a directory named after the output of this date command. So you can see how useful that is. Like, like, you want to do that. and let's play around with that a bit, because that's like really useful. So you can do things like this as well. So mkdir, now we're going to give it the input, which is the converted output of the state command. Y dash underscore M D. There we go. And now you can do things like this. Journal. And then ls. There. See how nice that is? And then every day you want to make a journal, you just run this command again. If it's not a new day, then you can't do it. So you could even set up bash to like make this automatically for you. Really useful to know that you can convert output to input using backticks. The output of the program date, the current date formatted as year, month, day, with dashes in between, was used as an argument to create a directory with mkdir. An identical result is obtained using $, open close paren, instead of back quotes. Oh, that's a good one too. So it's just like, as I said in there's always more than one way to do the same thing in bash, which can be useful depending on, like, if you're scripting, automating things, one way doesn't work, just try another way. You'll do the same thing. So I'll type that out just because. So let's remove that file that I made, and it's a directory, so I need to make it recursive, and then we'll do the same thing. Oh, or I could have just said rmdir, and then I don't have to get that error message. Okay, so now we're doing the same thing. Date plus okay, it's this one. Y dash M dash D, and dots will not work. We need date. ls. There we go. We've got the same file. Didn't specify journal this time. Let's do a rmdir on it. There you go. I don't have to specify an option now. The same method can be used to store the output of a command as a variable. Ooh, that's useful as well. So os equals backtick, or we can do the other one. Let's do the other one just to drive home the point that you can do the other one. All right, and then echo. Use this to call variables. And there we go. So you can see just how insanely useful that is. And this is a character. This is an instance where if I were to do, like, you'd think like, oh, well, what I want to do is feed the input from that command from the uname command into this variable as output. So how do you do that? Feed the output of the uname command to this variable as input to define a variable. So how do you do that? You use a pipe. Oh, and it works. Oh, see what I mean? Oh, we gotta do an echo. Oh, see what I mean? So it's like, it's not working in this case. So like, yeah, see, so like, this is a way, if it doesn't work to pipe, to redirect, to like, to do it that way, you can just convert it from output to input instead of like piping it, because pipe is a redirect, right? What is a pipe again? Yeah, I mean, pipe starts all the commands at the same time, and then it connects the output. Yeah, so like, you're feeding, like, maybe it would work like this. Now, see, it just doesn't work. So like, the pipe key isn't for that. The pipe key character tells the shell to start all distinct commands at the same time and to connect the output of the previous command to the input of the following command. See, like this command doesn't take input. Like, I mean, I guess it does, but like, it doesn't take it like in that way via a pipe. So you can do it this way via a surrounding it in backticks or using this syntax here. The same method can be used to store the output of a command as a variable. The command uname-o outputs the generic name of the current operating system, which was stored in the session variable OS. To assign the output of a command to a variable is very useful in scripts, making it possible to store and evaluate the data in many distinct ways. Depending on the output generated by the replaced command, the built-in command substitution may not be appropriate. A more sophisticated method to use the output of a program as the argument of another program employs an intermediate called xargs. The program xargs uses its content it receives via standard input to run a given command with the contents as its argument. The following example shows xargs running the program identify with arguments provided by program find. So now what we're doing is we're finding this file at this path, or sorry, what we're doing is we're finding something in this directory here with the file name, and this is a glob, DEBIAN star. So since it's a glob, the star is a special character and it means anything after. So in this folder, here we go. Here's all matches. So this is our output, our standard output from the find command. So now what we do is we plug that in to the xargs command as the input to the xargs command. So what the xargs command does is it uses the contents it receives via the standard input, which is this right here. Because what the pipe does is it takes the output here, converts it to input, and then feeds it to the next command. To run a given command with the contents as its argument. So it's going to run the command identify, and then it's going to do the format, and then here this is what is fed in there. So the example shows xargs running the program identify with arguments provided by the program find. So this is another one where it will wait until it gets input, and since okay, well, we don't have identify on my home lab. Let's see if I have xargs. I do. Okay, so let's see if I can do this. Interesting. Let me see what this does. Yeah. So there's like, oh, maybe because I didn't get any matches. Yeah, maybe that's why. Let's find something that says like txt. Oh, I don't even have this. Let's do this. Find dot dash name txt. Oh, I think I need globs. Okay, here's my glob. There we go. So we found all sorts of things that have txt in it. So let's try feeding this into the identify command. So we're going to use xargs to explicitly convert the output to the input, but I don't understand why we would need to do that because the pipe already does that. Okay, this is interesting. Oh, I didn't get the first. I didn't get this. That's what's going on. I got this. I thought I did. Oh, okay. So, okay. Yep. So, this is the same. This is same thing saying, you know, we don't have identity. Let's try it with something else then. Let's try it with word count. And there we go. We've got the standard output printing to the screen, and then we've got yeah, because xargs is kind of like T, I think, is what we're talking about. I don't remember. So the built-in command substitute. Oh no, xargs is an alternative to using these substitution characters to convert the input to the output. So what we're doing is we're converting the input to output. So here's the output. It gets output, and then the input is still fed to the WC command. So we're getting both. We're getting the input and the output. The output we're feeding to the bash screen, and then the input we're feeding to WC. So we can do it without the xargs command, but if we do that, we won't see the input fed to WC. Yep, all we get back is the output from WC. Okay, so the program identify is part of image magic, a set of command line tools to inspect, convert, and edit most image file types. For me, just have that basic built-in file command. Don't really have need for this yet, so I won't install it. In the example, xargs, I need some water quick. Took all paths listed by find and put them as arguments to identify, which then shows the information for each file formatted as required by the option -format. The files found by find in the example are images containing the distribution logo in a Debian file system. -format is a parameter to identify, not to args, to xargs. Yeah, so yeah, we can see. Yeah, I knew that. So like xargs takes input. The input is the output. No, what xargs does is it converts output to input. So like the output of find would be placed here as and the pipe converts it to input. So then what xargs does is it takes this input and it converts it to output, and then it puts it here, and then the output from the command after xargs is put wherever the command tells it to go. In my case, I did it with WC, so it was just put out on the screen. We could also do it to a file, but you can see the difference is when you have the xargs, the input you feed to WC gets converted to output and therefore displayed on the screen. And then you also run the command WC, which is here. But if you don't include the xargs, you don't see that input because all that happens with it is it's fed to WC. It is not converted to output and displayed on the CLI. All right, so option -N1 requires xargs to run the given command with only one argument at a time. In the example's case, instead of passing all paths found by find as a list of arguments to identify, using xargs-1 would execute command identify for each path separately. Using -N2 would execute identify with 2 paths as arguments, -N3 with 3 paths as arguments, and so on. Similarly, when xargs process multi-line contents, as is the case with input provided by find, the -L can be used to limit how many lines will be used as arguments per command execution. Note, using xargs with option -N1 or -L1 to process input generated by find may be unnecessary. Command find has the option -exec to run a given command for each search result item. If the paths have space characters, it is important to run find with the option -print0. This option instructs find to use a null character between each entry so the list can be correctly passed by xargs. The output was suppressed. Oh, now we're getting... Oh, okay, so print 0... So we're finding within our current directory any file named with the last 3 characters in it, AVI, and then here's a glob symbol that means any characters before that. Then what we want to do is use a null character between each entry so the list can be correctly parsed by xargs. So here's each entry. Oh, you know what? No. Here's each entry. Print 0 comes at the end of each entry. Yeah. So what we're doing is we're doing multiple finds. The first thing we're trying to find, and this is specified by print 0, is the files.avi. Then we're using a null character. Yeah, so this is basically like saying this is not part of the string to... This is not part of like what we're trying to find. This is a separator between each entry. You're explicitly saying that so that you feed multiple standard outputs from the find command into xargs. Otherwise, it would like just try to... It would be invalid syntax. And let's try that. Let's try that without the print zeros and see what happens. All right, so I'll just do it. So we'll do it with txt files. So we'll do it with whatever makes sense. So this is what makes sense to find files in my current directory, and we're gonna search for files using a glob symbol. We'll use the glob symbol asterisk to mean any character any number of times until you match with txt. Then we're not going to include the print 0. Let me see what the -o is. Okay, so -o means man, that's really tricky. I don't know what that means. Let's ask the AI.
O operator in the context of the find command is a logical OR operator. When used within an expression, it allows you to combine different tests or conditions. If either the expression before or the expression after the O is true, the entire combined expression evaluates to true. Here's an example that can illustrate the usage of the O operator. This command will search a specified directory for files that have either a txt extension or a log extension. It will return true for any file that meets either of these conditions. Understanding these logical operators will help you write more complex and powerful commands, an essential skill that can benefit you in nailing job interviews and working in networking environments, which aligns with your bigger goals.
Okay.
Goals, have you had a chance to practice your medium level LeetCode questions today? Along
So-
with your Anki cards, focusing on these tasks will show
yeah. The answer is no to all those questions. So, when would you need to use -print0 in this context?
Print 0 action in the find command is particularly useful when dealing with file names that might contain special characters, such as spaces, new lines, or other characters that could be interpreted specially by the shell. Using print 0 with find will print the full file name on the standard output, followed by a null character, ASCII 0. This null character acts as a delimiter between the file names, ensuring that even file names with spaces or other special characters are handled correctly. This is often paired with tools like xargs, which can read these null delimited strings with its -0 option. Here's an example that demonstrates this usage. This command will find all txt files in the specified directory and remove them. If any of the file names contain spaces, new lines, or other special characters, they'll be handled correctly because of the combination of print 0 with find and -0 with xargs. Understanding this can prove useful in scripting and automation tasks, which could be relevant to your end-course Cisco exam and in general.
Okay, great. So, what this does is, if it finds a file name, for example, like let's make a new file, and we're gonna have it be another .txt file. Let's say call it like a .bak file. So we're gonna make two files. We're gonna say touch example.bak, and we're gonna do touch example example.bak or bak. There we go. So now we've got a oh, that's weird. You know what? We've got to wrap it in single quotes. Okay, there we go. Now we've got the file. So if we were to go like this, find -name, and use a glob symbol, and then bak without the -print. Ooh, that's interesting. We're gonna find it. Yeah, we're gonna find it. But if we feed it into something like xarg, and then we just do like a cat. Oh, I thought it was. Oh, it has an S. Okay, so let's fill in that a file. So, um, okay, there we go. So now, if we were to just do it without that, we get the same result, which is we match on these two files. But now if we feed the output of those two files as input into cat, then we will get, then we will just cat out the file names. Okay. Let's do xargs cat. There we go. Now we get we convert the we convert the input into output. So, then why don't we get the file name? I'm confused. All right, well, let's try it with print-0. Or -print0. What the hell? I thought -print0... I thought the opposite would happen. Like, when I didn't include -print0, I thought I would get this message, and then I just include this message, and then this goes away. Where did the null go? Here? All right, well, I'm confused. That's okay. Nothing new. I'll just read all this, and then that will be the end of the video. If the paths have space characters, and this is for space characters. Okay, yeah. So okay, let's try it with space characters. This is so frustrating. So we're gonna remove all files with the BAK extension, which sounds like a good idea. Okay, using a glob symbol. Now we don't have any. Then what we're going to do is create a new file name. So we're going to do touch. We're going to say 123 space abc.bak. There we go. Now we've got a file with a space in it. So then what we're going to do is we're going to find in my current directory all files with the name any character using a glob symbol and BAK. Right, and we found one. We found that 123 space ABC file. Now what we're going to do is take the output and feed it into the command WC, or into the command cat as input. Or we're going to feed it to the command echo as input. And okay, I'm confused now. What about cat? Okay, so we're going to take the output have this command, and we're going to feed it into cat, and then what gets displayed is the output of cat. Now, if we were to do xargs, it should, yeah. So it tries to do it nicely, but you can see it actually reads it as 2 files because of that space character. So instead, what we can do is -print0, and now that space character is a null character, which cannot be passed through in the argument list. Oh, you know what? Maybe that's because I don't have any more arguments. So let's do a -o. Then we'll do -name. I think it's only if you have multiple arguments. It's used to differentiate between the two. So use the glob symbol again, and we're going to do the txt files. Okay, now we're not going to include the -prints. And we are off to the races here. Let's not use cat. Let's use ls. Okay, yeah, ls isn't bad because it ls is still kind of bad. Let's use wc. Okay. Oh, you know what? We're using xargs. All right, there we go. All right, now let's do xargs. Let's clean up some of these .txt. There we go, and let's make a touch test.exe. All right, now this is better. What? Oh, you know what? Because it's searching everything. It's searching all of the folders as well. Shoot. Okay. Well, let's not search for txt. Let's search for img. Oh, it's taking standard input. Okay. Oh, I messed it up now. All right. Well, I'm done. Like I said, I just want to close this out, and once we start getting into the hour-and-a-half mark, the video is just too long. Okay. So the option -uppercase 0, which I do not see in the upper line, maybe we'll see it in the lower line, tells xargs the null characters should be used as a separator. That way, the file paths given by find are correctly parsed even if they have blank or other special characters in it. The previous example shows how to use the command du, which I do not see. Oh yeah, here it is. Here's du. To find out the disk usage of every file found and then sort the results by size, which would be nice because I don't have a lot of space on my computer, not my home lab, but my computer I'm running this on. Well, I'm running Chrome on here in this case, so that would be great, and I could do that in my WSL. The output was a Windows subsystem for Linux. The output was suppressed for conciseness. Note that for each search criteria, it is necessary to place the -print0 option for find. By default, xargs places the arguments of the executed command last. To change that behavior, the option -uppercase I should be used. So uppercase I will place will reverse the arguments of the executed command. In the last example, every file found by find is moved to the current directory, as the source path or paths must be informed to MV before the target path. A substitution term is given to the option -I of xargs, which is then appropriately placed alongside MV. By using the null character as a separator, it is not necessary to enclose the substitution term with quotes. All right, so guided exercises are going to take some time. So the video is already too long. So that's it. Stay tuned for the next video with the guided and explorational exercises.